Hi, everyone. It's Coach Fred here, and I'm going over a couple of questions that came up from the homework that people sent to me. So I'm going to just review. 1 and 2 are very similar to what we did in class, so I really think you should look at your notes and try those. But I specifically want to go over like question number 6 and number 7, where it just asks you, what's the domain and the range? So I want to remind you, domain is your x values, all the x values that fall on the graph, and all the range is all the y values. So if we look at number 6, remember you want to scan the x-axis, which is this one, and this is the y-axis. So for domain, since it's the x values, you want to scan from left to right the x's. So let me just pick a point on a graph. So right here, this ordered pair would be -1, 2, okay? So that means that on the x-axis, the -1 ordered pair works. So it's going to have an x-coordinate everywhere along the graph until it gets to this point right here. So I want everything less than that point. So that point is 1, 2, 3, 4. So I want all the x's less than or equal to 4. And that would be the domain, okay? Now the range, I know that this is hard to see, but the range is all the y values. Now you have to imagine these arrows tell me that the graph goes on this way forever and on this way forever. So what that means is if it keeps going, it's always going to have a y coordinate, always. And when something always is going to have a coordinate, that means it would be all real numbers. So that's that funny R, okay? All right, let's try it again. Let's look at this graph. So if I look at the x-axis, I'm looking for the domain. I look along the graph. Look, everywhere along the x-axis, there is going to be an x value. Every single place, there's going to be an x coordinate. So that means it's going to be all real numbers. Now, y's, we scan up and down, right? We scan from bottom to top. Well, this graph, if I go bottom to top, the lowest part of this graph is right here. And the highest part of this graph is right here. So what are the y values there and there? So the y values there are -1, right? That's the y value right there, -1. And this one is 1, 2, 3, 4, 5. So I have 5 and -1. So I want all the y's between 5 and -1. So again, looking at the bottom and the top y values. All right, let's look at this one. This one's actually a little bit easier, number 8. If I look at the x's starting on the left, it looks like the first x value is -1, okay? And the last x value would be, let's see, 1, 2, 3, 4, 5. Okay, so I have -1 and 5. Now, do you notice there's a closed dot here and an open dot here? So look at how I'm going to write that. I want the x's between and equal to -1, but just less than 5. That's because that open circle means it's getting as close as possible to 5, but it doesn't quite reach it. So that means it's just less than. Okay, my range, I'm going to look at my low value, which looks like -3, and my highest value on the graph, which looks like +3. Again, it would be y's. I want y's between -3 and 3. All right, this is something that needs practice, so hopefully that part helped. I'm going to move on to, I just want to look at numbers 15 to 22. We didn't quite get to this in class, and it says, determine whether the relation represents a function. So we are going to be reviewing this in class tomorrow, but also I want to go over it now. So a relation is a function if every x has one unique y. Every x has one unique y. Well, over time, that has become really tricky for kids to understand. So what I always say to students is, look for repeated x values that are the same. Repeated x values. If you look for repeated x values and they have different y's, it is not a function, okay? So not a function. If it doesn't have repeated x values, then it is a function. So here's what I mean. I see -2, 2, 3, 4, 5. No repeated x values, so then yes, it's a function. All right, let's look at this one. I see a -3 here and a -3 here. So I have repeated x's, so I look to see if it has different y's. It does have different y's. It has a 2 and a 1, so that tells me it's not a function. All right, let's look at 17. I have a repeated x here and here. So I look to see if those y's are different. The y's are different, so it has a repeated x with a different y, so no, not a function. All right, this one's a little harder. Mapping makes it a little bit harder. So I look at this 6, okay? So if I were to write that as an ordered pair, that would be 6, 3 and 6, 5. So it's a repeated x with different y's, so not a function. All right, this one's just a scatter plot, a discrete graph. All right, so I have an ordered pair here. It looks like 1, 2, 3, 4, -4, 2. I can see this is a different x value, this is a different x value, this is a different x value, and this is a different x value. It has no repeated x's, so yes, it's a function. Okay? All right, hopefully that was a helpful video. Have a great day.